In this video, I'm going to talk about the flash ADC. The circuit diagram for a flash ADC, or the schematic of a flash ADC, is shown on the screen. In this diagram, each of the triangular elements that are shown here is a comparator. If you remember the function of a comparator gives you a high output if the input at the non-inverting terminal is higher. It would give you a low output if the input at the inverting terminal is higher. Okay, this block is a coding block, and we'll look at the function of it in just a moment. Okay, so how does this ADC work? The basic idea is that this resistor ladder introduces or makes sure that there are different voltages introduced at different points to the different comparators. So the non-inverting input of each of these comparators, let's call them 1, let's number them from down. So 1, 2, 3, 4, 5, 6, and 7. So each of these comparators get a different voltage at their non-inverting inputs. And these voltages are then compared with the analog input. And depending on what the analog input is, you would get some comparators having their outputs high and some comparators having their outputs low. And this coding block then converts that into a 3-bit binary output. Okay, so the first thing that we should try to understand is what are the voltages that would come at these points. So let's start, for example, from the voltage at comparator 1. So how many resistors are connected above this point? It's 1, 2, 3, 4, 5, 6, and 7 resistors. Okay, so the voltage at this point is going to be simply 10, which is the voltage, which is the power supply here, 10 volts, times R over 8R. So that 8R because there are 8 resistors there. Okay, so which is also, let me write it as 10 over 8 volts. So the voltage here is 10 over 8 volts. Now, of course, we are assuming in this case that the current that goes into each of these comparators is 0. Okay, and we can assume that because in most comparators that are available in the market, the input impedance of those comparators is very high and the input current is very, very low. Okay, so let's continue and look at the voltage at this point. So you have 8 resistors in total, and you have 2 resistors below. So the output at this point is going to be 10 times 2R over 8R. Okay, and that's going to turn out to be 10 times 4 volts. Okay, look at the voltage here. It's going to be 10 times 3R over 8R, and that's going to turn out to be 10 times 3 over 8 volts. And this would be, again, in a similar vein, this is going to be 10 times 4 over 8 volts, or 10 over 2 volts. This is going to be 10 times 5 over 8 volts, 10 times 6 over 8 volts, 10 times 7 over 8 volts. Okay, so basically what we have done here using this resistor network is that we have taken this scale from 0 volts to 10 volts and divided it into 8 parts. So at the center we have 10 over 2, which is 5 volts, and then you have 7.5 volts, you have 2.5 volts, so this is 10 over 4, this is going to be 10 times 3 over 4. Okay, and then you divide it further into another 2 levels. And now depending on where the analog voltage is, so let's say for example that the analog voltage is somewhere here, okay, then the 3 comparators that compare this analog voltage with respect to this voltage, and this voltage, which are going to be our comparators 1, 2 and 3, they are going to give a low output, and comparators 4, 5, 6 and 7 are going to give a high output, right? And that gives us an indication as to which of these bands the analog voltage lies, so in this case we know that all these values are 1 and all these values are 0 or low, so the analog voltage lies in this band. And the coder can use this information and figure out what 3-bit binary output corresponds to this value, right? So you could, for example, start to code for this level, and you can decide various kinds of codes. But if you call this 0, 0, 0, and you call this level 0, 0, 1, this level 0, 1, 0, this one 0, 1, 1, and 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So the coder gives one of these codes depending on where the analog value is. So if the analog value is here, the coder decides, okay, the 3-bit binary output is going to be 0, 1, 1. Hopefully that helps with understanding the flash ADC.